Hello all and welcome to the Math 8 video for two-step equations. Now in previous sections, previous topics, we've talked about one-step equations, okay? So now we're going into what we consider two-step equations, okay? So we're up in the complexity, up in the difficulty just a little bit here. And then also in between there, we did talk about rational equations. Well, there are such things as rational two-step equations, as you'll see when we look at the examples. So knowing how to deal with fractions and decimals is also relevant when you're talking about two-step equations, okay? But with that being said, with two-step equations, we are talking about equations that are in this form, okay? Well, technically there's two forms of two-step equations, okay? And the first form we're going to talk about is this form where we say Px plus Q equals R, okay? And notice here I've got the X box. There's arrows pointing to it because that is the variable we need to focus on in terms of that's where the variable is that we need to solve for, okay? So what we can think of is this P, this Q, and this R. These are all just numbers, okay? So this also goes for subtraction, but in that case, if we wanted subtraction, we would just make Q a negative number. Same thing if we wanted division here with multiplication and division. Instead of multiplying times P, we could just technically make P a fraction, so like 1/3 or 1/2 or something. But that's neither here nor there because, once again, what we need to focus on here is the form, meaning we have the variable we're looking for times a number, then plus or minus another number, and then it's equal to yet another number, okay? So in this case, we're focused on this variable here. Now, this variable that we need to solve for, it's a two-step equation, but there are technically 4 steps that you need to do here. Now, where we get two-step equation, that's what these 2 steps in the middle come from, okay? Because the first and last step aren't really steps that you have to follow every single time, in that you don't have to consciously think, okay, locate the variable every time. You don't technically have to check your solution every time, but it is good to always check your solution with an equation because that way you can guarantee you got the correct answer, okay? But first step, as always, is locate the variable, meaning what are we needing to solve for? In this case, we need to solve for what's right here with x, okay? Now, the 2 steps that we have here, okay, and part of the reason I've got stars by them here for the two-step equation is they have to be done in this order, meaning we have to undo the addition or subtraction before we undo the multiplication and division, okay? And where that order comes from, okay, if you maybe can kind of got a hint by looking at the screen here, something else we have the word order in is how the order of these steps go depends on the order of operations, okay? Because the way you need to think about it is, and you'll see this when we look at some of the examples here in just a minute, is this is the variable I need to solve for. What am I doing to x? Well, order of operations wise, I would be multiplying times p, then I would be adding q, okay? So the order of operations tells us what we're doing to x. So if we plugged in a number for x, we would multiply it times p, then add q. So that means, and you notice I've got an arrow above the order of operations here, we have to undo the addition first. Well, how do we undo addition? With subtraction. So that means instead of adding q, we need to subtract q. Okay, and that's my first of the 2 steps. So first step is subtract q. So undo the addition or subtraction, subtract q here. Then we undo the multiplication or division. So then we would divide by p. So the way you can think about it is multiply times p, then add q. That means to solve the equation, I need to subtract q and then divide by p. So you're always doing the opposite backwards. So going backwards and doing the opposite, okay? And this is very important because we didn't have to worry about this with one-step equations, because if there was only one step, there was one operation for us to do, there's really no order to put one thing in, okay? But when we have two steps or two operations we have to do, we have to honor order of operations. And in this case, that means going backwards with order of operations because, once again, the process of solving an equation, we're basically undoing all the operations that are done to the variable we're looking at, okay? So what that means is, since we multiply times P, then added Q, that means we need to subtract Q, then divide by P. And it has to be in that order, okay? And that's the most important thing to learn and know about two-step equations is the steps have to be done in order, okay? So with that being said, and just to make it known here, said it earlier, every time you get a solution to an equation, you can always check it, as I'll mention here when we look at some of these equations and the examples, okay? But first up here, we have the equation 9 times a minus 2 equals negative 65. So we're starting this off with a bang in terms of, see that negative 65 right there? That probably makes some people have some anxiety because a bigger negative number here. Okay, when I say bigger, I mean the 65's a bigger number. Okay, but we have negative 65. But what we need to focus on here is that's just a number. 2's just a number. 9's just a number. So the variable we need to focus on is this a. Okay, so we need to ask ourselves, well, what are we doing to a in the equation? What's happening to a? Well, we're multiplying it times 9, then we're subtracting 2. Okay, in that order, multiply by 9, then subtract 2. So that means to work backwards from that order, that means we have to add 2 first. Okay, get rid of the 2's here, so we get 9a is equal to, this is, once again, where people get into some trouble with some negatives, but that should be negative 63. Okay. And then, if you've paid attention the last couple sections, this actually is now a one-step equation where our one step is to divide by 9. So in this case, we get a is equal to negative 7. Okay. Now, how did I know to do the addition before I did the division? Well, the equation told me. Because once again, if I plugged in a number for a, what am I doing to a? I'm multiplying times 9, then I'm subtracting 2. So working backwards and doing the opposite, that means I need to add 2, which was the first step. Then I needed to divide by 9, which is the second step. So first step here. So first step. And this was second step. Okay, and that's why we call it a two-step equation, because we had to do two operations. We had to add 2, then we had to divide by 9. Okay, now number 2 is going to work very similar. We have negative 4 times x plus 7 equals 31. Well, x is our variable. Okay, so what are we doing to x? Well, we're multiplying times negative 4, then adding 7. Okay, we don't care what's going over here with the 31 just yet until we start doing our operations, because first things first, we need to know what steps we need to do the operations in. And those steps are, in order, subtracting 7. Okay, once again, you can draw the line here if you need to. 31 minus 7. Go ahead and say that's 24. And then, of course, the last step, well, the first step in our equation, or the first thing in our equation would be to multiply times negative 4. So that means the last step in solving the equation would be to divide by negative 4. So that means we get x is equal to positive over negative is a negative. 24 divided by 4 is 6. Okay. Now, as I've said before, these equations, once you get an answer, plug it back in and see if it doesn't give you what's, something true up here, meaning we plug in negative 7. 9 times negative 7 is negative 63. Negative 63 minus 2 is negative 65. Negative 4 times negative 6 is 24. 24 plus 7 is 31. Okay, so we actually use the order of operations when we check our equations too. So you're getting order of operations all over the place here. And that's why order of operations are so important. You need to know, okay, what am I doing first? What am I doing second? So that tells me in order my first step of the equation and my second step. My first step was here, minusing 7 or subtracting 7. And then my second step was dividing by -4. Now, number 3 looks a little bit more difficult because we introduced division here, but it works the same way in that order of operation tells us, first off, our variable's k, and what we're doing to k. Well, first we would divide by 3, then we would subtract 11. And once again, all this is equal to -5, so just reading out the rest of the equation there. But k divided by 3 minus 11 equals 5, -5. But once again, we don't really care what's over here until we start doing our operations. But first, we need to know what order we need to do them in. So that means since we're dividing by 3, then subtracting 11, that means my first step is actually to add 11. So we get k over 3 is equal to 6. Okay, and the whole point here is those 11s go away. And then since we're dividing by 3, the opposite of that is multiplying times 3. And the whole point here is to get rid of the 3, so we get k is equal to 18. And once again, you can check your work by plugging in 18. 18 divided by 3 is 6. 6 minus 11 is -5. Okay, all this hinges on order of operations. But then we get to one like number 4. Okay, now you kind of maybe remember from one-step equations, things can be flipped around a little bit. So you can have things flipped over the equal sign, okay? Or you can have the variable term and a constant term flipped around. Well, here it's actually both, meaning we see the variable is w. It's on the right-hand side of the equation, and actually the variable term comes after the constant term, meaning we have 8 equals 23 minus 5w. But my suggestion is, first, I'm going to rewrite this so everybody can see that you can flip things around if you need to. So all I did was flip the sides here. So my variable will be on my left-hand side. And now, and this is a little trick that you'll definitely learn how to do because this will happen over and over and over again, is that if I want to flip this around to make my variable term in front, the negative has to go with the 5, okay? And one way you can think about it is, well, there's nothing in front of the 23, so that means it's a positive or a plus 23, okay? So now when I want to flip it around, I just flip these two around. So I do -5w plus 23 equals 8. And now I have an equation that looks like what we did up here with number 1 and number 2, where w's here, we're multiplying times -5, then adding 23. So that means we need to subtract 23, which is -15 over here. So 8 minus 23 is -15. Then we divide by -5. Negative over a negative is a +5. 15 divided by 5 is, so w in this case is equal to +3. And once again, plug that back in. 5 times 3 is 15. 23 minus 15 is 8. Okay, so when we plug 3 back in here, even though things are all kind of flipped around and everything, we can manipulate, and this is what we talked about when we simplified expressions and things like that. We can move our constant terms and variable terms around, but get in the habit of, once again, if you do that, you don't have to necessarily move things around. You could have seen at the beginning we needed to get rid of this 23, so I needed to subtract 23. Then that would leave you with a -5w, so then I would divide by -5, okay? The steps are still the same, so first step, second step, okay? But the whole point here is sometimes things will be flipped around and messed up, so make sure you know how to manipulate terms, manipulate expressions, simplify things in order to get it into a form you know how to work with, okay? But all in all here, once we solve the equation, the answer is 3. W is equal to 3. Numbers 5, 6, 7, and 8, very similar here, except once again, back with number 5, we're back into something that's a little bit easier because everything's kind of laid out nicely for us. The only problem with number 5, as you'll see here in just a second, is we do get a weird answer out that people normally kind of mess up with sometimes. But let's see what that is. Well, m is my variable, so 8m minus 11 equals 11. So that means, oh wait, I think there's a little bit of a typo there, or a right-o. That should be a negative 11 here, so that's my apologies. Go ahead and add that in. But in this case, we have 8m minus 11 equals negative 11. Okay, so same kind of thing. What are we doing to m? Well, we're multiplying times 8, then subtracting 11. That means my first step needs to be add 11. And that gets rid of those, so we have 8m is equal to, and this is where it gets a little tricky, negative 11 plus 11. Technically, we could say those cancel out, but what does that mean? Well, that means those cancel out to be 0, okay? But once again, this is still a valid equation because now we have a one-step equation where 8m is equal to 0, so we would just divide by 8. M is equal to 0, okay? So you can't have equations, have solutions be equal to 0. Now that doesn't mean that there's no solution here. That means the solution is actually 0. Whatever m represents, that means m is 0, okay, for whatever it is. So just be careful here. Where people tend to mess up is they flip this around and they try to do 8 divided by 0. But as we all know at this point, you can't divide by 0, but you can divide 0 by something else, meaning 0 divided by 8 is just 0. And you can double check that on your calculator. But notice the steps here, okay? Multiply times 8, then subtract 11. That means my steps are add 11, divide by 8. Okay? Now number 6, kind of like number 4, things are kind of flipped around. So if we need to, we can flip it around. But let me just show you don't have to do that. We see the variable here is n. So we can think of it this way. We can think, well, what would we do to n? We would divide by negative 4. Then we would add 1 or add it to 1. But the same kind of thing here is where this is addition. We could flip this around, no problem. We could have n over negative 4 plus 1, okay? But the step is going to be the same in that since this is addition here, we need to take care of it first. So how do we get rid of a positive 1 here with addition? Well, we would subtract 1, okay? And then the same thing would have to happen over on this side. We'd have to subtract 1, so we get negative 7 is equal to n divided by negative 4. Okay, and then that means my last step here is to, since I'm dividing by negative 4, I need to multiply times negative 4. I am using parentheses just so I don't mix it up and think that I should be subtracting here or anything. That's the problem with negative sometimes. But in this case, the negative 4s will go away, so we get n, negative 4 times negative 7, positive 28. Okay, and we can do the same thing. Plug in 28 up here. 28 divided by negative 4 is negative 7. 1 plus negative 7 is negative 6. Okay, but like I said, don't let the flipping things around, don't let that mess you up. And like I said from number 4, if you need to, flip the equation around to have the n on the left-hand side. Okay, flip the terms around here so that way you have the n term first, the variable term first. Okay. And we see the same thing with number 7. Now, number 7, this is one that a lot of people, I've had students actually say this in class before, that this looks like a one-step equation. And I can see why people would think that, because you've got 19 minus x. There's no number in front of the x, and that's equal to 30. Okay? But this is kind of a two-step equation in disguise, because if we do the little thing of flipping around here, well, technically there should be a 1 in front of the x. There's a 1 in front of the x. So if we flip things around, that makes this negative 1x. There's a positive 19, so negative 1x plus 19. And now this looks like number 5 here, or number 1 or 2 that we did earlier, where what are we doing to x? Where we're multiplying it times -1, then adding 19. So that means I need to subtract 19. I guess I should draw my line here. -1x is equal to 30 minus 19 is 11. Divide by -1, so that gives me x is actually equal to 11 divided by -1, -11. Okay. But like I said, just like number 6, just like number 4 before it, don't get frustrated or don't get confused by the flipping around of terms or flipping around of the equation. Like I said, if you need to, do this little process here where, once again, where did this -1x come from? Well, it came from I had minus x, minus 1x. So since the negative has to go with the 1, it has to go, if you change it to the front, it has to go with the 1. Same thing here. Technically, there's nothing in front of the 19, so we understand that it's a positive 19. Well, that means if you flip it over to be the second term, that means you've got to add 19. That's a plus 19 since you have a positive 19, okay? And then we technically could do the same thing here with number 8. R is our variable. We're dividing it by 2 and then adding it to -17. But like I said, if things are flipped around, do this little process of, okay, here's my two terms, plus r over 2. Well, that's positive r over 2, so let's just do positive r over 2. -17, so minus 17. Once again, all I did here was flip the terms around so that now, this now looks like what we did with number 3. We have the variable over a number minus another number equals yet another number. So r divided by 2 minus 17. Okay, so we would do r divided by 2 first. Then we would subtract 17. That means my first step here needs to be to add 17. And same kind of thing here. Just draw our line. So the 17s go away. So we have r divided by 2 is equal to -25 plus 17 is -8. And then our last step should be multiply times 2. So we get r in this case, which that is not an r. R is equal to -8 times 2, -16. Like I said, just like every other equation, you get the answer here. -16 divided by 2 is -8. -17 plus -8 is -25. Okay, so don't let the negatives fool you. Don't let the, don't let the flipping of terms and flipping of the equation mess you up. That's why, once again, when we talk about simplifying equations, learning how to flip terms around and learning how to do the things here in terms of flipping the equation around, if you have to do that, that's something you can do to help you solve equations, okay? But now we go to number 9. If we look at number 9, still a two-step equation, except the only difference here, starting with number 9, is we have a decimal, okay, or we have decimals in our equation. Well, how do we deal with decimals? Well, we deal with decimals the same way we would any other number, in that here is my variable x. I have 0.4 times x plus 9 equals 11. So what am I doing to x? Well, I would be multiplying times 0.4, then adding 9. So that means in order, I need to subtract 9. Okay, so whole point here, the 9's go away, so we get 0.4x is equal to 11 minus 9 is 2. And then what would we do next? Well, since we're multiplying by 0.4, we need to divide by 0.4 on both sides. So this is x is equal to, and this isn't something I expect you to be able to do in your head, although this one's not that difficult of one, okay, if you know how decimals work, and you can move decimal places over if you needed to, or multiply both top and bottom by 10, I guess, if you really wanted to do this without a calculator. But in this case, do 2 divided by 0.4 in your calculator, and you'll find that the answer there is simply 5. Okay, so x is equal to 5. But once again, don't let the decimals trip you up, mess you up, because the steps are still the same. We multiplied times 0.4, then added 9. That means my steps have to be subtract 9, divide by 0.4 in that order. Okay. Now, number 10, this is probably the trickiest one out of the whole set here because we've got negatives and subtraction everywhere. But once again, I strongly suggest, okay, we got the variable over here. Some of us might be able to see, well, technically my first step would be to add 10, and then I would divide by negative 1.5. Those are the steps in order. But if you don't see that, well, first off, let me do this. Okay, so all I did once again here, just like I've done before, is I've just flipped the equal sign, flipped across the equal sign, meaning whatever's on the left is equal to the right. Well, now what's on the right is on the left. What's on the left was on the right. And if you do that, that's fine, because if two things are equal, it doesn't matter which order you put them, they're still going to be equal. Okay. Now, with that being said, now we still have the problem over here where we have a negative minus something. Okay. So negative 10 minus 1.5 m. But it's the same thing here. If we really needed to, we could do this little technique where we know the negative has to go with the 1.5. We know the negative has to go with the 10. So if we flip these around, this is going to be negative 1.5 m minus 10 is equal to negative 18. And now from here, once again, it's a lot of negatives and subtraction going on here. But now from here, we know what the steps should be, because we have m, we're multiplying it times negative 1.5, then subtracting 10. So that means my first step needs to be to add 10. So in this case, negative 1.5 m is equal to 8. And then just to give us some room here, let me rewrite this up here. But same kind of thing. We have negative 1.5 times m, so that means we need to divide by negative 1.5. Okay, so those go away. So we get m is equal to negative over negative is a positive. And this one actually turns out to be pretty nasty, because if you plug that in your calculator, 8 divided by 1.5 is 5.3 repeating. Okay. And once again, just like before, and in this case too, the equation originally had decimals in it. So in this case, it would actually be okay if you wrote your answer as a decimal. But at the same time, it is a decimal that repeats, because you get 5.333333333 on and on and on. So you need to indicate somehow, if you write it like this, indicate somehow that the 3 repeats, and also that it goes on forever. And that's what this line does right here, 5.3 repeating. All right, and then number 11 should be a little bit easier here, although we do still have a negative. But once again, focus on what the variable is here, which is v. We're doing v, so we're going to divide by negative 0.8 first. Then we're going to add 14. So that means in order we need to subtract 14. Once again, we can draw our line. So we get v over negative 0.8 is equal to, in this case, we have 39 minus 14, which is 25. Okay. And then last step here is, since we're dividing by negative 0.8, we need to multiply by negative 0.8. Notice I am, once again, using parentheses here, so that way I don't mess up and think that I'm subtracting 0.8, because once again, it all depends on what the opposite is here. We're dividing by 0.8, negative 0.8. We need to multiply by negative 0.8. So here we get v is equal to negative times a positive is a negative. 25 times 0.8. Okay, once again, not something I'd expect you to do in your head. If you're clever about it, you can figure this out pretty easily. But once again, not necessary, because if you do have a calculator, 25 times negative 0.08 is going to be negative 20. Okay, and then once again, you can check it by plugging this back in. Negative 20 divided by negative 0.8. Okay, well, that's going to be 25. So negative over negative is a positive 25. Plus 14 is 39. But then we get to number 12. And I'm going to put some stars by number 12. Okay. Same thing with numbers 13 and 14. So I'll go ahead and put stars by them. So for when we get to it. Because the way you work all of these questions is going to pretty much work out the same. And the thing that you notice right off the bat, probably some of you, when you looked at this, you probably immediately saw the fraction. But the thing we have to understand about fractions are they are just numbers. So the way we solve equations with fractions is the exact same way we solve equations with any other number. Okay? So it's the same kind of thing. Our variable is x. Well, what are we doing to x? Well, we're multiplying it times 2/3, then subtracting 7. So the first step here is actually really easy. Let's just add 7. Okay, so that point here, we got that. 2/3 x is equal to 12. And now we run into a part where this could look pretty difficult. Okay, but it actually works out to be pretty nice here because, once again, technically what are we doing here? We're multiplying times 2/3. So one thing we could do is divide by 2/3. Okay, but this looks pretty nasty, and actually dividing by fractions is really nasty because we got 2 fraction bars here. Technically here we got 3 fraction bars. Who knows what's being divided by what? So kind of like we talked about in one-step equation videos in the video, same thing goes here, is that if you ever need to divide by a fraction, you can instead multiply by the reciprocal, meaning the fraction is 2/3, its reciprocal is 3/2. And the whole point here is we do 3 times 2 is 6. 2 times 3 is 6. 6/6 is 1. These essentially cancel out to be 1, and we get 1x. So we have x is equal to, in this case, if we did multiply times 3 halves on one side, got to do it to the other. 12 times 3 is 36. Divided by 1 times 2 is 2. So 36 divided by 2. X in this case is, so let me move it down a little bit, is 18. Okay. But once again, technically what you could do here is divide by 2/3. So you could go over here and where we're at this point, divide by 2/3. Now, if you're plugging this into a calculator, I do suggest maybe putting parentheses around stuff so that way you can tell what your denominator and numerator are. Okay. But if you do that, the whole point here is the 2/3 go away to give us 1x. And then 2/3, 12 divided by 2/3, if you plug that into your calculator, you'll see it's still 18. Okay. So don't let fractions trip you up either, because if you have a fraction, it works just like any other number. It's just how we deal with fractions sometimes. In this case, like I said, if you needed to divide by a fraction, you technically don't have to do that. You can make it easier on yourself by just multiplying by the reciprocal. But with the way we have calculators and stuff now, especially the Desmos calculator, you can divide by fractions no problem. You just got to know how to type it in correctly, okay? And that's where, once again, I strongly suggest if you do type it in the calculator, if nothing more than to check, do figure out how to use the parentheses there so that way, like I said, when you're working these out, you can tell what the numerator and the denominators are, because with fraction over fraction, that can get kind of messy, kind of look a little weird, okay? But the answer here is 18 because, once again, we would get 2/3 of 18. So 2/3 times 18, that's 12. 12 minus 7 is 5. Number 13 and 14 work exactly the same way, except the only thing with number 13 is the whole equation's been kind of flipped around, but that actually doesn't matter. We're looking for C. We're multiplying C by negative 5/8, then adding 9. So that means my first step here would be to subtract 9. So we get negative 10 is equal to negative 5/8 C. Okay. And this is a little tricky if it's over here, but it's the same kind of thing. Technically, if you wanted to, you could go through and divide by negative 5/8. But once again, that looks super nasty here. And you see I'd already put the parentheses around there just to let it be known like that's my denominator. But like I said, you don't have to divide by a fraction. Okay, instead, what you would technically do here is instead of dividing by negative 5/8, you can multiply times negative 8/5. Multiply times negative 8/5. And once again, I'm using parentheses here to just single out my numbers. So the whole point here is we do negative 5/8 times negative 8/5. Same as last time. Negative times a negative is a positive. 5 times 8 is 40. 8 times 5 is 40. 40 over 40 is 1c. Okay. And then over here, we can just put that over 1. Negative times a negative is a positive. 8 times 10 is 80. 5 times 1 is 5. 80 over 5. It's a little tricky, but you can do that in your calculator pretty easy, and you find out that that's just 16. Okay. So the answer to number 13 is 16. But once again, if you need to, just double check yourself. You can plug this back in up here. Negative 5/8 of 16. So negative 5/8 times 16, that would be, in this case, let's see, negative 10. Okay. The negative 10 plus 9 is negative 1. But like I said, if you don't understand or you're having trouble with this whole idea of multiplying by the reciprocal, I do have to say this is something that's going to show up a lot in algebra, though. So when you get to actual algebra class, you got to learn to multiply by the reciprocal. But at the same time, when we get to this point, we could simply just divide by negative 5/8. But like I said, I do strongly suggest, especially in the calculator, put parentheses around everything so that way you know what your numerator is, what your denominator is. So now when it goes through, those will go away. C, if you do in the calculator, negative 10 divided by negative 5/8, negative over negative is a positive. 10 divided by 5/8 is going to give you still 16. And then number 14, you could probably guess this is going to work the exact same way. This one's actually a little nicer for you, though, because m's just right here. You're multiplying m times 1/3, then subtracting 16. So that means we need to add 16 first. 1/3 m is equal to 15. And then at the same time here, okay, we're multiplying times 1/3, so you can technically just divide by 1/3. Okay. But like I said, dividing by fractions is nasty. It's ugly. It's hard for some people. Okay. So instead of having to divide by 1/3 here, what we can do, and this is actually really easy because what's the reciprocal of 1/3? Well, that would mean we just multiplying times 3 over 1. Okay, which is just the number 3. So you can literally just multiply 15 times 3. But just to be consistent, technically it is 3 over 1 because here 3 times 1 is 3, 1 times 3 is 3, 3 over 3 is 1m. And then here we got 15 times 3 is 45 over 1. That's just 45. So m is 45. Okay. And then once, as always, plug it back in. 1/3 times 45 is equal to 15. 15 minus 16 is negative 1. But just to be, like I said, just to be consistent, once we get to this point right here, technically what you could do, especially if you have a calculator, is divide by the 1/3. So in your calculator, you technically just have to do 15 divided by 1/3. But at the same time, once again, doesn't hurt to use parentheses to say 15 is my numerator, 1/3 is my denominator, but it would still give you 45. Okay. So the last part of the two-step equations are dealing with another form of two-step equation, which once again, if you deal with equations and you look at the order of operations, that should be all that you need to know. Because once again, if you look at this form, we have x here, which is what I've said we're going to solve for. Okay. So if x is what we're going to solve for, then we're going to add q, then we would divide by p, and then that's all equal to r. Once again, just think of p, q, and r as just numbers. But if we have x plus q first, then we divide by p, that means first thing we have to do is undo the division, meaning we have to multiply p by, or both sides by p first, then we can subtract q. So you can kind of think that the middle two steps here kind of reverse in this case. But why that is because of order of operations. We would be adding q first. So we would be adding q first. Then we would subtract, or we would divide by p. So that means first step is to multiply times p. Then the second step would be to subtract q. So let me just go ahead and show you what I mean by that. So there's just 4 examples of this, but you got to really pay attention. So once again, we look at this, x minus 1, all of that over 6. And that's the main point here is it's not just x being divided by 6. It's not just 1 being divided by 6. It's the whole thing, x minus 1. And if it helps you, since the whole thing up here is being divided by 6, put that in parentheses. That doesn't hurt a thing. And actually, that kind of helps you see, well, the fraction bar here is kind of a grouping symbol. Because what does it do? Well, it groups the whole numerator together because the whole numerator is what's being divided by 6. But what does that mean from order of operations standpoint? Well, that means x minus 1 has to happen first. Then we can divide it by 6. So that means, working backwards and in order, we need to multiply times 6 first. And once again, the whole point here is to get rid of that. So we get x minus 1, which is what's on top, is equal to 12. And like I said, still do the line there if you need to. And now, after we do that, that was the first step. That was the first step of the equation. Now we just have one more step, which is just simply add 1. So x in this case is 13. But I can't reiterate enough that the order of operations matters here, because what are we doing to x? If we plugged in a number for x, so let's plug 13 in for x. Well, if 13's in for x, we would do 13 minus 1 first, which is 12. And then we would do 12 divided by 6, which gives us the 2. Okay? So once again, the whole thing about these is order of operations. And as I've done before, the arrow going backwards. You're working backwards, okay? But in this case, if you're working backwards, it still looks like you would do addition and subtraction first, then multiplication or division. But it really depends, okay? Well, technically, if we put the parentheses around here, x minus 1's in parentheses. Well, what happens? When do we do parentheses stuff? Well, actually last. Whatever's in parentheses is what we do last. So if you think of the fraction bar as being a grouping symbol, same thing with number 16. We can put the m plus 17 in parentheses, and that tells us that's what we're doing last. Okay, so if we look at number 16, 9 is equal to m plus 17 in the parentheses or on the top here. And all of that, m plus 17, is being divided by negative 2. It's not just m being divided by negative 2. It's not just 17 being divided by negative 2. It's the whole thing, m plus 17. So that means my first step here needs to be multiply times negative 2. Okay, and the whole point here is the negative 2's will go away. So we have m plus 17. Negative 2 times 9, that's a negative times a positive is a negative. 2 times 9 is 18. Same thing here, you can draw your line. But then we see that all we got to do is subtract 17. So what we get here is negative 35 is equal to m, or m is equal to negative 35. Because you can do the same thing here, okay, in that you can flip this around and write it like this first. And then it's the exact same steps. Multiply times negative 2. Boom. M plus 17 is equal to negative 18 minus 17 minus 17. M is equal to negative 35. Okay. So everything that we've talked about with two-step equations still holds, even if we have equations of this form. The thing you got to recognize is when you have something like this, it's not just the x being divided by 6. It's not just the 1. It's the whole thing, x minus 1. And like I said, it doesn't hurt a thing. And if you want to get in the habit of this is a perfectly fine habit to get into, is that put parentheses around your numerator there to say the x minus 1 is together. Okay, and all of that in parentheses is what's being divided by the 6. Okay, so that means, once again, we would do x minus 1 first, then divide it by 6, means, okay, the steps in order have to be multiply times 6, then add 1. Okay, and that's exactly what the steps here that you see. Multiply times 6, add 1. And then we get to the last two examples. Number 17, very similar to what we just did with number 16. Things are flipped around, so if you absolutely needed to, you could go over here and write it like this. K minus 5 all over 16 is equal to negative 3. So same equation here, except for, once again, we need to figure out, well, k minus 5, that whole thing's being divided by 16, so the first step is we need to multiply times 16. Once again, I'm going to put parentheses in here so I know it's not 16 minus 3, it's 16 times negative 3, which is negative 48. And then we get k minus 5, so our next step is to add 5, which would be negative 43. Okay, and you can see the same thing by working it in the other direction here, but the point here is the steps are still the same. Like I said, I got a negative here, so I'm going to put parentheses around it. Those go away. K minus 5 is equal to negative times a positive negative 48. Add 5, add 5. K is, in fact, still negative 43. Okay, but like I said, the whole point here is look at the variable. Well, what would you do to the variable in the equation? Well, you would subtract 5, then divide by 16. That means my first step has to be multiply times 16. Then my second step would be to add 5. And it has to be in that order. If you do it out of order, who knows what you're going to get. Here you would get, you would add 5. You would get, so you get 2, and 16 times 2, you get 32. We'll plug 32 back in. 32 minus 5, well, that's 27. 27 divided by 16, that's definitely not negative 3. Okay, so you can tell by just checking your equation, but when you plug in 43 here, or negative 43 minus 5 is negative 48 divided by 16. Negative over a positive is a negative. 48 divided by 16 is 3, so you get negative 3. And then the last one here, okay, p plus 20 over 7. Well, once again, the p plus 20 is kind of where the fraction bar is there. It kind of acts as a grouping symbol. It takes that p plus 20 and groups it together, so you can put parentheses around it. But in this case, that tells you would do plus 20 first, then divide by 7. So that means we have to multiply times 7. So the whole point here, those go away. P plus 20 equals negative 4 times 7 is negative 28. And then we would subtract 20. So P in this case is negative 48. Okay. And just as always, take that and plug it back in. So we plug it back in. Negative 48 plus 20 is negative 28. Negative 28 divided by 7 is negative 4. Okay. So once again, the whole point of all of this is you have to follow order of operations, even when solving an equation. If you don't follow order of operations when solving an equation, then you're not going to solve the equation, okay? Because if you think about it, front ways we have to do order of operations. So when we plug it in here, so negative 48, we have to add 20 first before we divide by 7. That's what the order of operations tell us. So that means, and it's just the nature of solving equations, if we're working backwards, we're trying to figure out what P is, then that means we have to do the opposite going backwards, meaning we would have to do the multiplying by 7 first. Then we can subtract the 20. Okay, and you can tell what the steps are just by looking at this. P plus 20 divided by 7. So P plus 20 first, then divide by 7. That means multiply times 7, then subtract 20. It has to be in that order. Okay. All right, and then the last thing here, so a nice little fun activity for you. So this is just all practicing with all sorts of different kinds of two-step equations. Every single one of these is two-step equation. Set one, if you look at your paper there, set one are all ones like numbers, basically I think 1 through 8. Same thing with numbers from set two, so all the equations in set two, basically like 1 through 8. And then the last set, that's the trickier ones. That's like everything 9 through 18 here, in that, once again, ones where you got to pay attention to fractions. You might have decimals. You've got, well, in this case, no decimals, but you got fractions. And then you've got this idea where you have to pay attention to order of operations. So you got to do your multiplication first before you do your addition or subtraction. Okay. But make sure you read the directions on that. Okay. So what you're going to do is each set, you're going to solve each of the equations in the box, and then you're going to match up the answers, meaning one equation from the first column is going to be the same as one of the answers in the second column. Well, those will match up, meaning whatever equation number there is there, then that's what you're going to put in the box, is the letter from the other equation. Okay, so once again, kind of maybe a little bit confusing, but if nothing else, practice all the equations there, because this is really good two-step equation practice for the homework. But when it's all said and done, the riddle is, how do you make 7 an even number? How do you make 7 even? Okay, well, it's kind of a corny joke here, but that means equation B matches up with equation 1. So you get B, Y. So equation Y matches up with equation 2 in set 3. And so on here. So I'm just going to fill it out, but you can make 7 an even number by taking, so Taking, so equation T with 3, A with 4, K with 5, I with 6, N with 7, G with 8. So by taking so THE, once again, same kind of thing, equation 9 and equation T, equation 10 and equation H, equation 11 and equation E. Those are all going to have the same answers. And then 12 is S, so taking the S out. So O with 13, 14 with U, 15 with T, and then, of course, 12 with S. So how do you make 7 an even number? Well, 7, how do you make it even? Take out the S, and then you have even. But anyways, once again, the whole point in this is get a good practice with two-step equations. All the equations on the sheet, which I know there's technically 30 of them. Okay, so a lot of equations, but once you get in the rhythm of solving a two-step equation, I do strongly suggest trying to do all these in one sitting, just so you can really get in the habit, once again, seeing how these equations work, get a feel for them. But go through, solve all those equations, practice. If you run into any problems, as always, let me know. But if you go back and just look at how we did all the other examples here, that should help you with all those equations. And then, of course, as always, you got the homework there. So definitely let me know if there's any problems before you do the homework, or if there's something you don't understand with the homework. Please let me know. Okay. But other than that, good luck on your homework, and thank you for watching.